Sorry, sir.
Sorry, I'm not able to hear you. Are you able to see?
Yes, sir.
Okay, we'll get started. Get started. Yes. So we get started with next chapter. But before that, do you have any doubts from the previous chapter? First, all the completing. Any doubts? Any problem that was come? No. So then we'll get started with the next chapter, that is applications of derivatives. Right. So first, we'll see what is the introduction. Right. So for us to understand the chapter, we need to understand what we exactly did in the previous case. So in the previous case, what did we do? Right. We try to understand the derivatives of different functions. Meaning, we try to understand how the tool is used to differentiate different functions. Right. So we saw the derivative of composite functions. We saw the derivatives of inverse trigonometric functions, implicit functions, exponential functions, logarithmic. Right. Then we saw what is double differentiation. So now we are clear with how to differentiate a given function. Right. The next step that we are supposed to understand is how to apply the constant in reality. So that is what this chapter is all about. That's why it's named as applications of derivatives. So in applications of derivatives, what happens is we'll be studying about the derivatives in various disciplines. When I say disciplines, it can be like engineering or pure science or wherever you have the social science and many other things, right? So it depends on the situation. So depending on the problem statement, we will be needing a tool called as differentiation to understand or to solve. Are you able to understand that? Right. So in this chapter, what we are particularly going to understand is how to determine the rate of change of quantity. So if there is a physical quantity that is changing with respect to time, how can that rate be calculated? Okay. Second, with respect to mathematical parameter, that is a function, we will understand how to use differentiation to understand whether the given function is increasing or decreasing at right? Increasing or decreasing. And the third type is we will try to frame the equations to given curves, right? For a given curve, we'll try to frame the equations for two important lines, which are called as tangent and normals. Okay, so we'll be forming for tangent and normals to the given curve at a given curve. And fourth, what we will calculate is we will calculate the maxima and minima of a given function. So that is, we will try to understand where a function is attaining maximum value and where is the minimum. Am I clear with this? So this is what. First, just make a note of it. Right. Right. So in today's class, we'll be concentrating only on the first part of this chapter, that is the rate of change of quantities. Right. So if you look at a quantity, when you say a quantity, it can either be a physical quantity or a mathematical. Right. So this you have learned in your physics also. Right. For that matter, you will be learning in your chemistry also. Like if there is displacement, right? So can that change with respect to time? If there is displacement and if it's changing with respect to time, what do you call that? So how do you define it? You define it as the rate of change of velocity, right? So if there is displacement which is changing with respect to time, you call it as velocity. Similarly, if there is velocity which is changing with respect to time, you call it as acceleration. Right now, the question is, how are these quantities written as? So, can I write V is equal to ds divided by dt? And what can you write A as? A is written as dv by dt. So, this changing with respect to time, you can call it as rate. So, can I also call it as rate of change of velocity? Can I call this as rate of change of displacement? Right. So, everywhere what you're doing is you're basically differentiating a parameter with respect to another. Am I right? So, in this exercise, all that we are going to do is differentiate one physical quantity with respect to another. To put it very simple, you will differentiate the variable with respect to the independent quantity. That is all we need to do. So I'll explain it with proper examples. Suppose you can make a note of Listen to this. Those who are online, are you able to understand?
Yes, sir.
Okay. So I'm clearing this. Yes. So, since we told that the rate of change of quantities is going to take place in such a way that the variable will be differentiated with respect to an independent variable. The dependent variable will be differentiated with respect to an independent variable. The way we write it as dy by dx. Right. So, in some scenarios, we put a line like this and write it as x is equal to x. The meaning of this is dy by dx at x is equal to x naught. So x naught is some number. So what you do is first differentiate, then take that number and substitute it in the place of x. Okay. Or this can also be called as f dash of x naught. So f dash is the first derivative, we call it as dash of x naught also. Are you able to understand? So this is how we actually find the rate of change of quantities. This is what we need to apply. Right. So only thing is everything will be the problems will be given in the form of statement. You need to convert them into mathematical expressions and then differentiate. Okay. Make a number. There is not much theory in this. It's all about So let us look at the first example. The question is, find the rate of change of area of a circle per second with respect to its radius r when r is equal to 10 centimeters. So the meaning of it is, there is a circle. Okay. And what is happening to the circle? Its radius is changing. Because, read the question, find the rate of change of the area. So basically, what is the area of a circle? Area is pi r square. So area is a function of radius. So area will be able to change only if there is a change in radius. So what is happening to the circle is, the circle is either expanding or getting compressed, so that for every second there is an increase or decrease in the radius change. Okay. So at one particular instant, right? So you need to find the rate of change of area of the circle per second. Read this carefully. You need to find the rate of change of area per second with respect to its radius. When r is equal to 5 centimeters. So what I did first is I wrote a is equal to pi r. So to be more specific, you write it as a of r is equal to pi r square. Meaning, I'm trying to say it is not a into r. I'm trying to say that a is a function of r. Okay. So what do I need to do? I need to find the change in area of the circle with respect to its radius. With respect to differentiate with respect to that point. So all that I need to do is I need to find dA divided by d. Right. So it is going to be 2 pi into r. Right here. So dA divided by dr at r is equal to 5 centimeters. Take this value and substitute it here. You will get the answer as 10 pi. But listen to the units here. area is measured in centimeters square per time. Radius is measured in centimeters. So basically 10 by centimeters square per centimeter. So cancel. So what is the meaning of this? Area is changing at a rate of 10 by centimeters square with respect to each centimeter. So when there is a change in area of a radius of one value, it is increasing by 10. With respect to its radius. So whenever you say with respect to, you need to differentiate with respect to that. Answer will be 10 by centimeter square per. Yep. Maybe they are expecting us to write the units, but you need to differentiate. But we differentiated with respect to our with respect per second go to per second go, but it's actually 10 centimeters square per centimeter. That's what we have done. Find the rate of change of area of a circle per second. See, we have to differentiate it with respect to time. I'll tell you why I didn't do it. If I did with dt, then what would be the answer? You will have 2 pi r. Will I stop with it? Into, I should write dr by dt when this has not been given in the question worked. They didn't tell what is the rate at which the radius is changing. Had it been in such a way that the area of the rate is changing as 1 unit per second, then the 10 centimeters square per second. Then dimensionate that be the value observed. Now I can write this as centimeters square per second. But here how will you? So try to understand the meaning of it. What is the meaning of it? Don't look at the number. What is the meaning of it? So for each increase or decrease in 1 centimeter radius, there is how much change taking place in the area. 10 by centimeters square is taking. That's the meaning. When I increase or decrease the radius, see one or if you have to visualize, let's assume there is a circle. The circle basically starts at the point, right? So its radius is increasing. So when its radius is increasing, what is happening to its area? That is also changing. What is the speed at which it is changing? What they have asked. Is that clear? Shall I proceed? So look at the next question. The volume of a cube, right? Volume of a cube is increasing at a rate of 9 cubic centimeters per second. Meaning, if I take the volume of the cube to be V, then dV divided by dt is equal to how much? 9 centimeter cube per second. Right. Having said this, how fast is the surface area increasing when the length of an edge is 10 centimeters? Okay, so if I take a cube, like this, whose side is A, right? So what is happening here? How fast is the surface area increasing when the length of an edge is 10 centimeters? So you need to first analyze the question. So what is the volume of a cube? V is equal to A cube. So what is the surface area of a cube? So when they simply say surface area, they mean total surface. If it is curved surface area, lateral surface area, they will mention. So if I take the total surface area to be S, then S is equal to 6A square. What are they asking is, what is the value of ds divided by dt? Now listen to this. Yeah, I'll solve the problem, but I want you to understand the context. So here, first the volume or area is increasing due to change in which parameter? Both are dependent only on one parameter. What is it? Dependent on the side. Means the side is changing with respect to time, due to which there is subsequent increase or decrease in this case it is increasing. Subsequent increase the value of surface area, also in the case of volume. Are you able to understand this point? So they have mentioned that dV by dt is 9 centimeters cube per second, meaning for each second, the volume of the cube is increasing by a unit of 9. Right? Means in the second, what would have been the value of volume? It would have been 81. Sorry, 80. You are right. It is 80. Right? It keeps increasing in that way. Are you able to understand? So, based on this parameter, since we know that V is equal to A cube, if I differentiate on both the sides, what will I get? dV by dt as 3a square, but I cannot stop with it because you are differentiating with respect to time, not with respect to a. So into, I will write dA divided by dt. Now plug in the values. Take this 9 and put it here. 9 will be equal to 3a square into dA by dt. From this I can conclude that dA by dt is equal to 9 will cancel, 9 will get cancelled 3 times. It will be 3 divided by a square. Let me call this as 2. The reason why they gave this one is find dA by dt. Okay. So having said this, if you observe, all I need to find is, if I know s is equal to 6a square, I need to find ds by dt, which is going to be 12a into dA by dt. Don't forget this. Because I am differentiating with respect to time. So it is going to be 12a into, from the previous slide, we know that dA by dt is 3 by a square. Plug it there. So if you put it here, it is 3 by a square. A and a will get cancelled. I will get the answer as 36 divided by, correct only, no? This 36 divided by a, right? But what do I need to find? The ds by dt when the value of a is how much? 10 centimeters. So if I take ds by dt at a is equal to 10, then all that I need to do is write it as 36 divided by 10, which will be 3.6. What is going to be the unit? Centimeters square per second. So this is the rate in the equation. Are you understand? So for me, the important thing is you need to analyze it. Answer will get it. Did you understand how to find which one is dependent and which one is independent one? Right? Start. Shall I proceed?
Yes, sir.
Did you all make a note of this? Computer. Wow. So try the next one. So the next question. Listen to this. The third question is the stone is dropped into a quiet lake and waves move in circles at a speed of 4 centimeters per second. Right. So when you see from the top view, right, whenever a stone is dropped into water, still water, what kind of shape? They take the shape of circles, right? Right. So here they say that the waves move in circle at a rate of 4 centimeters per second. Did they give it a centimeter or centimeter square? Centimeter. So the meaning of it is radius, sorry, dr divided by dt. I'm sorry, wait. Meaning is dr divided by dt is equal to 4 centimeter per second. At the instant when the radius of the circular base is 10 centimeter, when r is equal to 10 centimeter, what is the value of dA by dt? That's what the question is. So what is the value of area? Area is pi r square. We need dA divided by dt. So that is going to be 2 pi r into dr divided by dt. Right. So what is the value of r? R is equal to 10 centimeter. Put it here. So you have 10 pi into what is the value of dr by dt? It is 4. Answer will be 45 centimeters square per second. It is 4 only. Oh, 20. Okay. It is 85 centimeters. Shall I proceed? That's all. Could you solve this? Solve this or not? No? Yes, something. Easier. Here, do the next. You will see that most of you are not able to do. Listen, how many of you saw this? So listen, if I take a rectangle whose length is x and the breadth is y, okay, the length x of a rectangle is decreasing. So length is dx by dt is equal to minus 3 centimeter per minute. Why minus? Because they use the word decreasing. Whereas the width y is increasing at a rate. So dy divided by dt is how much? 2 centimeter per minute. Right. When x is equal to 10 and y is equal to 6, find the rate of change of the perimeter and area of the rectangle. So what is the perimeter of the rectangle? So perimeter is equal to 2 into x plus 1. Right. So which implies dp divided by dt is equal to 2 into dx by dt plus dy by dt. So this will be equal to 2 into, what is the value of dx by dt? It is minus 3. Plus, what is dy by dt? It is plus 2. So 2 into minus 3 plus 2 is minus. So here you get minus 1 multiplied by 2 is going to be minus 2 centimeter per minute. Meaning, when the length is decreasing at this rate and the width is increasing by this rate, the perimeter is still decreasing. That is why you get a negative. We don't know what is going to happen to the area because it's dependent on the number. Right. Now, if I talk about the area of this rectangle, area is going to be equal to x into y. So what is dA divided by dt? X into dy by dt plus y into dx by dt. So dA divided by dt will be equal to, what is the value of x? X is equal to 10 centimeter, y is equal to 6 centimeter. So x is 10, but what is dy by dt? 2 plus y is 6 and dx by dt is minus 3. So here what is going to happen is it will be 12 minus 18, answer will be minus 6 centimeters square per minute. Meaning the area is, sorry, so 20 minus 18, then it is going to plus. Correct this. Yeah. So this is going to be 20 minus 18, which is going to be 2 centimeters square per minute. So here the meaning is. So what is happening here? The area is increasing at the rate of centimeters square per minute, whereas the perimeter is decreasing. Here, I hope you got an idea of this. Make a note of this. Those are completed, you need not wait for me, go to the next problem. You keep solving the exercise problem. Fifth problem, the cost, those things that you need not do the marginal part. Okay, that problem alone you leave, others you can proceed. So you want to please make a note of this. Shall we proceed? Shall we start with the exercise problem? The question is, find the rate of change of the area of the circle with respect to its radius. See, this should have been the first examination. This is how it works. Find the rate of change of area of the circle with respect to its radius r when r is equal to 3 and r is equal to 4. So A is equal to pi r square. dA divided by dt is 2 pi r. When you substitute r is equal to 3 here, you get 6 pi centimeter square per centimeter. Right? Sorry, not dt, it is dr. Similarly, dA by dr, when r is equal to 4 is going to be 8 pi centimeter square per centimeter. Simple problem. Shall I proceed? Second. The volume of a cube is increasing at a rate of 8 centimeter cube per second. How fast is the surface area increasing and the length of an edge is per centimeter? So dV divided by dt is equal to 8. Right? It is 8 centimeter cube per second. Surface area is 6a square, which implies ds by dt is equal to 12a into dA divided by dt. Right. So here we know that d is equal to a cube, which implies dv by dt is going to be equal to 3a square into dA by dt. Right. So what is dv by dt? This 8 no. So 8 is equal to 3a square into dA by dt, which implies dA by dt will be equal to 8 divided by 3a square. Take this value and substitute it here. Then you will get ds divided by dt will be equal to 12a into 8 divided by 3a square. A and a will get cancelled. It is 96 divided by 3a. Actually, it will be 32. So 32 by a. But what is the value of a? When the edge is increasing at a rate of 12. So how much will the answer be? If you get a fraction, you can leave it as fraction also. 8 by. So it is going to be 8 by 3 centimeter square per second. 8 by 3 centimeter square per. Variable. It is a variable. Variable cube na it just changes. Question is there. About dA by dt. V is equal to a cube. dV by dt 3a square into dA by dt. A was 10. After 300 into 3, 900. A square, when a is equal to 10 is that. Let me see. The third one. The radius of the circle is increasing uniformly at the rate of 3 centimeters per second. So dA by dt is equal to 3 centimeters per second. Find the rate at which the area of the circle is increasing. So find dA divided by dt when r is equal to 10 centimeters. Okay. So capital A is equal to pi r square, or I'll write it as pi small a square. Okay. So d capital A divided by dt will be equal to 2 pi a into d small a divided by dt. So it is going to be 2 pi into what is the value of capital A? Means small a. So A is equal to 10, no? So substitute 10 here. Into dA divided by dt is going to be 3. So 3 into 2, it is going to be 60 pi centimeters square per second. So it's going to be 60 pi centimeters square. Here it is. Pi small letter, pi is just a variable there. I use small a for radius, capital A for radius. Okay. Shall I proceed? An edge of a variable q is increasing at the rate of 3 centimeters per second. So dA divided by dt is equal to 3 centimeters per second. How fast is the volume of the cube when the edge is 10 centimeters? How fast the volume of the cube increasing when the edge is 10 centimeters long? So volume of the cube is a cube, which implies dV by dt is equal to 3a square into dA by dt. Here it is. So this is going to be 3 into what is the value of a? It is 10. So 10 square is going to be 100 into what is the value of dA by dt? It is going to be 3. Answer will be 900 centimeter cube per second. It is going to be 900 centimeter cube. 4 by 3. Online, are you able to understand? Those who are online, are you able to understand?
Yes, sir.
Okay. Can I proceed? These are all simple ones. This is also similar to the example one, right? A stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeters per second. At the instant the radius of the circular wave is 8 centimeters. how fast is the enclosed area increasing? Dropped into a flat lake, the speed of the radius, so dr divided by dt is equal to 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast this area is increasing? So dA by dt, when the value of r is 8 centimeters, is how much? So area is equal to pi r square. So dA divided by dt is equal to 2 pi r into dr divided by dt. So r is equal to 8 substituted here. So it will be 16 pi into what is the value of dr by dt? It is 5. So how much are we going to get? We will get 85 centimeters square per second. Okay. 85 centimeters square per second. Done. So proceeding to the next one. 6th one. The radius of the circle is increasing at a rate of 0.7 centimeters per second. So dr by dt is equal to 0.7 centimeters per second. Find the rate of increase of its circumference. So circumference is equal to 2 pi r. So what is dc divided by dt? It is going to be 2 pi into dr divided by dt. So it is going to be 2 pi into dr divided by dt is 0.7. The answer will be 1.4 pi. So pi you can write it as 22 by 7. So that is 1.4 into 22 by 7. How much is it going to be? 0.2. Answer will be 4.4 centimeter per second because it is circumference per time. Is that point clear? It will be 4.4 centimeter per second. We'll end with this. Remaining problem is what we tomorrow, and tomorrow itself we can start increasing. So what are the starting with? So those are online, we can find the course.
Thank you, sir.
Yeah.